and today I'm going to be talking a little bit about my science fair project. Well, actually, I'm working with a partner on this science fair project, Crystal over here. Hey, Crystal.
Yes.
So, you didn't want to talk in that video?
No.
Why not?
Because
why?
Because I'm not good in front of cameras.
Interesting.
Very.
And we're working on a project to help fix Alzheimer's, or work on it for that matter. So our project involves using some electronics and some other cool stuff. So let's dive into what it's about. So our project is about Alzheimer's, and Alzheimer's is this leading disease in our society. It's common in old people, and what happens in Alzheimer's is plaques build up inside the brain, and it causes your brain not to function as well. These beta amyloid plaques build up in between the cells. Now, gamma waves inside the brain aren't gamma waves like the radiation that you may be thinking of, but gamma waves are actually kind of like one of the sub-processes that are going inside the brain. It's the speed at which the neurons fire in kind of a circle. So, in order to measure the gamma waves in our project, to measure the effect of different stimuli on our gamma wave production, we actually modified or built an EEG machine. So what happens is the gamma waves inside the brain, when there's a rising gamma waves, it can actually trigger these glial cells inside the brain to actually clean up the beta amyloid plaques. And when that happens, it can reduce the symptoms of Alzheimer's. And so in the MIT research, they confirmed that an increase in gamma waves can actually trigger these glial cells to clean up the beta amyloid plaques. And they also figured out that you could actually stimulate gamma wave production using 40 cycles of light fired into a mouse's brain. So with a 40 hertz light flashing, I'm able to trigger gamma wave production inside the brain. And so the basis of our project is to figure out other ways to stimulate this gamma wave production inside the brain using other methods other than light. Because although light works, we may be able to find something that works better, and light can also cause nausea, and I kind of got a little bit sick while wearing this. And there's just better ways of doing it. Now, the human body has 5 senses, and we wanted to figure out another way to introduce a 40 hertz signal into the body to stimulate the brain at 40 hertz besides using light, because we could try shining the light into people's eyes at 40 hertz, but that could cause some issues such as nausea and trigger epilepsy. So another way we thought of introducing 40 hertz into the body to stimulate the brain at 40 hertz was through vibration. Now, I've actually gone through a few different prototypes with vibration apparatuses to vibrate your body at 40 hertz, but this is the final product, the best one, and it is this office chair that I've converted into a massage chair that vibrates the whole chair and your body at 40 hertz. So the first prototype for the device that vibrated at 40 hertz was this, and it was a GoPro chest strap mount harness, and the harness was strapped onto the person's chest, and there was this stepper motor, and the stepper motor would vibrate at 40 hertz because it would step at 40 steps per second approximately. And it was hooked up to a motor driver and Arduino, so that way it would be precise in its steps. Now, the issue we had with this was that it heated up the motor, and it wasn't very powerful in its vibration. The second prototype was this device that was basically a wooden block with a motor, and the motor had a little counterweight on it, so the motor would vibrate. Now, the way I was able to fine-tune this was by using this piezoelectric element. The piezoelectric element is able to convert vibrations into electrical impulses. So I hooked this up to an oscilloscope, fired up the motor, and dialed in the voltage from the motor until we reached approximately a 40 hertz signal on the piezoelectric disc, and I found the exact voltage for the motor that triggered that 40 hertz signal was approximately 3.26 volts input. There we go, that's 3.26 volts. Now you can't see this, but this chair is vibrating a lot. So I originally had that device mounted to the GoPro chest strap. That worked very well, actually. It was able to vibrate the whole person's body at 40 hertz. It was pretty cool. But the only issue with that is it's a real pain putting on this chest mount harness, and although it's pretty cool, it's not the most economical thing, and it won't be able to be introduced into a person's life. So, our final product was this chair that leans back too much. Now, I actually found this chair on the side of the road, and it was trash, missing a wheel, got some stuffing popping out of it. But anyway, this chair works good for the purpose, and when you fire this up, the whole chair vibrates, and you can definitely feel that vibration inside it, which is pretty cool. Alright, so as I was talking about before, the way we're able to measure the gamma waves inside the brain is through this headset. This headset is actually from a Mindflex, and it's a game where you can levitate little balls floating on air. But what I'm doing right here is I've got this tapped into the serial output of a NeuroSky chip inside the Mindflex, and what's happening is it is connected to my ears as a ground, and it's connecting this probe to my head. Now what it's basically doing is it's taking a sample of all the electrical activity that's going on inside the brain, and it's kind of acting like a spectrum analyzer in focusing on certain frequency bands that the brain is producing, because the brain kind of works like a computer where it has different clock speeds, and it's just the frequency at which the neurons communicate with each other. So right now the spectrum analyzer inside the NeuroSky is tuned to focus on the 38 to 42 hertz spectrum inside the electroencephalograph, or EEG. Now, it's actually measuring kind of the amplitude of those waves, or how many gamma waves are actually being produced in that frequency range. And we can actually see the amount of gamma waves being produced over time. And so what I'm going to do right now is I'm going to connect this device up. I'm going to turn on the NeuroSky, and it's going to start reading my brain data over time. And we'll be able to see exactly what happens after vibration is induced. This chair is actually very relaxing. So this is the data that was outputted by our device. We achieved some actually really interesting results. So if you look over here, we have our 40 hertz vibration, and as you can see, with no stimulus, the gamma waves, there wasn't that much activity in the gamma wave spectrum of the brain. But then after we initiated the 40 hertz vibration, the gamma waves just jumped up a lot. And this is really cool because if you look at some of the other different tests we ran, such as sound, you don't see any significant difference between when the sound was activated and when it wasn't. Same with the vibration at a random frequency, you didn't see any difference. Same with the flashing light at 40 hertz. So this kind of confirms that the vibration at 40 hertz does in fact trigger gamma wave production inside the brain, which is very interesting, and this may lead to promising results in the field of Alzheimer's research, as if we're able to have someone stimulated by 40 hertz of vibration, then that could trigger their gamma wave production. Now, we don't have a way right now of confirming that this does indeed remove plaques from your brain, because we can't really cut someone's brain open, but we can use the MIT research to show that this is increasing gamma waves, and that those gamma wave increases will in fact remove the plaques from inside the brain. So that is a little bit of the basics of our science fair project, and we achieved some promising results. So we also ran the same test on a hospital EEG. That's me strapped into their fancy EEG machine. And as you can see, well, you can't really see because it's a little bit of a complicated graph, but we did see the same results as we saw from our ghetto EEG, which is cool. So that's our science fair project, and that's pretty cool. So now let me show you a little bit of ISEF. So, the plane is broke, so we're on the Great Migration to Gate A9. This migration is greater than some of the different penguin migrations, the different, like, animal migrations.